Okay, now we start section 4.3, multiplying, dividing fractions. Okay, section A, multiplying fractions. Rosie decided that she was going to devote 1/3 of her yard to a flower garden. She then planted 2/5 of her garden with some beautiful pink Gerber daisies that she found. What portion of her yard is planted with Gerber daisies? Now, we're given a visual picture here. And now we will write this as a fraction. It says, notice that the product turned out as we might have expected. We have 1/3 times 2/5. Now it says here the rule for multiplying fractions is multiply the numerator, so we'll take 1 times 2 is 2. Multiply the denominators, 3 times 5 is 15. Then simplify if possible. 2 and 15 has nothing in common. Even if we did the prime factorization, this would be 2 over 3 times 5. You have nothing that simplifies out, so it'll still just be 2 over 15. And that's it for that problem. Now, we go on to our next page. And we start here with our first example. So we multiply across 3 times 5 is 15. And 7 times 6 is 42. Now we've already done the prime factorization of 15 before, which is 3 times 5. And we've done the prime factorization of 42 before, which is 2 times 3 times 7. Now we can simplify. These 3's will simplify out, and you will be left with 5 over 14. Now we go here to number 2. 7 times 2 is 14. And 9 times 3 is 27. Now we would see with the prime factorization of 14, we know it's 2 and 7, and the prime factorization of 27, which we did before, comes out to be 3 set of 3's. And we have nothing in common, so our final answer will remain the same, 14 over 27. Now, there is an easier way of doing this prime factorization. Whenever you're multiplying fractions, why don't we just do the prime factorization first? The prime factorization of 4 is 2 times 2, and 3 is already prime, so we multiply that by 3. Now the prime factorization of 9 is 3 and 3, and the prime factorization of 10 is 2 and 5. So now we have all of the prime factorization. Now we have one set of 2's that are in common, and one set of 3's that are in common. So our final answer here would be 2 in the numerator and 15 in the denominator. And that's it. Now we go to number 4. We will follow the same process. We know the prime factorization of 8 is 3 2's. And then 3 is prime, so we multiply that by 3. And our denominator, the prime factorization of 15 is 3 times 5. And we know the prime factorization of 16 is 4 2's. Now, we simplify this out. We have 3 sets of 2's that are in common, and we have one set of 3's that are in common. So our final answer would be negative, our numerator would be 1, and our denominator would be 5 times 2, which is 10. So it's a negative 1/10. Now, looking here, we would have had to take the prime factorization of 24 over, it was what, so we would have had to take the prime factorization of 24 over 240. Now that would have been a lot more difficult to find a prime factorization of 24 and 240 instead of breaking it down like this here. Now remember, we can only do this with multiplication, nothing else. Now, with our next problem, we have a negative times a negative, so we know our final answer is. Again, with problem number 5, our answer is going to be positive. So what we need to do here is, we need to do the prime factorization of 5, which is 5, and the prime factorization of 9, which is 3 times 3. Now the prime factorization of 6 is 2 times 3, and the prime factorization of 14 is 2 times 7. Now because we know our final answer is going to be positive, we don't need to write the negative signs. Okay, now we have one set of 3's in common, and that's it. So 5 times 3 is 15, And 2 times 2 is 4, times 7 is 28. So our final answer here is 15 over 28. Now we go here to number 6. Okay, we have 6 times 3/8. We could put that 6 over 1 to make that a fraction. So in our numerator, 6 prime factorization is 2 times 3. And then this 3 is already prime. In our denominator, we know the prime factorization of 8 is 3 2's. So only have one set of 2's in common. So our final answer is 9 over 4. Now, I know this is an improper fraction, but we have not gotten to changing it to mixed numbers, so we would just leave it as an improper fraction. And also, just as a side note, an improper fraction is simplified when you simplify it out like we just did. Changing it to a mixed number is not simplifying. Okay, now we go down here to number 7. Now we know 7 is prime. I'm going to write it down here. 7 is prime, and we know 5 is prime. And we'll bring over our x. And our denominator, 10, the prime factorization of 10 is 2 times 5. The prime factorization of 8 is 3 2's. Then our denominator, we have x to the second power, so we will have 2 x's. Now, the only thing that they have in common as far as numbers are concerned are these 5's here. So we have one set of 5's we get rid of. Then we have one set of x's that we get rid of as well. So our numerator would be 7. And our denominator, we will add 2 times 2 is 4, times 2 is 8, times 2 is 16, times x is x. So it'll be 7 over 16x. Now we go to number 8. The prime factorization of 4 is 2 times 2. And the prime factorization of 5 we know is 5. But now we have 5 w's here because we had that w to the 5th. All right. Almost didn't think it was going to fit. Okay, now we had 25. Prime factorization of 25 is 5 times 5. Prime factorization of 6 is 2 times 3. And we had 3 w's. Now we simplify out what we have in common. We have one set of 2's, one set of 5's, and we had 3 sets of w's. So in our numerator, we would have 2w squared. In our denominator, we would just have 15. And that is our final answer. Now we come to section B, evaluating exponents on a fractional base. So now we have 2/5 in parentheses cubed. First thing we should see if we can simplify anything inside this parenthesis. We cannot. They have nothing in common. So all this really is 2/5 times 2/5 times 2/5. 2 times 2 is 4, times 2 is 8. 5 times 5 is 25, times 5 is 125. So that is our final answer. Now we have number 2. Same thing, we cannot simplify anything here. So we will write this as a negative 3/8 times a negative 3/8. A negative times a negative, we know is positive. 3 times 3 is 9. And 8 times 8 is 64. So it's 9 over 64. Now we go down here to number 3. Now the only thing taken to the third power is the 2, not the 5. So we'll have 2 times 2 times 2 all over 5. They have nothing in common. So this will just be 8/5. Now we go here to number 4. Now the only thing taken to the second power is this 3. Now the negative will still stay there, and we have 3 times 3 all over 8. Now this will give us negative 9 over 8. They have nothing in common, so that is our final answer. Now we go down here to section C. It says dividing fractions. The rules for dividing fractions is keep the first fraction the same, change division to multiplication, then take the reciprocal of the second fraction and then use the rules for multiplying fractions. Okay, now I know in the space that was provided for you, you may not have enough room to write all of this, so you may want to write it, below it or off to the side. But I needed to add all of this. This is the steps for dividing fractions. So what we're going to do is we're going to skip down. We're going to go to the next page, and we would take 6 over 1 divided by 1/2. Now remember, we keep the first fraction the same, 6 over 1. Division becomes multiplication, and we take the reciprocal, or as a lot of you have learned, to flip the second fraction. So now we multiply. 6 times 2 is 12, and 1 times 1 is 1. And we know 12 divided by 1 is 12. So that is our final answer. Now we go down here to these examples. Now again, we keep this first fraction the same, which is 2/5. Division becomes multiplication, and we take the reciprocal of the second fraction. Now we use the multiplication rule. 2 is prime and 7 is prime. 5 is prime, but 4 breaks down to 2 times 2. Now we have one set of 2's that are in common, so now we will end up with 7/10. Now we go to number 2. Now first thing, we should put this negative 33 over 1. So we will have negative 33 over 1. The division will become multiplication, and we would take the reciprocal of the second fraction, which would be a negative 11 over 6. Now, we know a negative times a negative is a positive. So we take the prime factorization of 33, which is 3 times 11, and then 11 here is already prime. And then now we have 1 times 6. Now, we don't have to take a prime factorization of 1. If 1 was the only thing left in our denominators, we will write it down. But since it's not, we will concentrate on this number here. 6 breaks down to 2 times 3. That is its prime factorization. Now we simplify out the 3's. And now we have 11 times 11, which is 121. And that's all over 2. And that is our final answer. Now we scroll down here. Now we have problems 3 and 4. Now 16 over 27 remains the same. Division becomes multiplication, and we take the reciprocal of the second fraction. Now, if you look here, this is a positive times a negative, so we know our final answer is going to be negative. So now, we would take the prime factorization of 16, which we know is 4 2's, and the prime factorization of 15, which is 3 times 5. The prime factorization of 27 is 3 3's, and the prime factorization of 8 is 3 2's. So now we simplify. Now we have 3 sets of 2's in common. We have 1 set of 3's in common. So our final answer we know is negative 2 times 5 is 10, and 3 times 3 is 9. So it's negative 10 9. Okay, now we start on number 4. We have 21x squared divided by 10y, and that is divided by 14x over 25y. So now first we must change this to multiplication. So we have 21x squared over 10y, and division becomes multiplication, and we take the reciprocal of the second fraction, which will be 25y over 14x. Now we would do our prime factorization of the numerator and the denominator. The prime factorization of 21 is 3 times 7, and then x squared we will write as x times x. 25's prime factorization is 5 times 5, and we'll bring down our times y. Now in our denominator, 10y, the prime factorization is 2 times 5, and we'll bring down our times y. Times 14 prime factorization is 2 times 7, and we'll bring down our times x. Now we simplify. If you notice here, we have 1 set of 7's in common. We have 1 set of x's and 1 set of y's. And we also have 1 set of 5's in common. So our numerator would end up being 15x, and our denominator would be 4. And we're done. Okay, on the next page, we have more examples. Number 5, we have 3/4 times 8/9 divided by 2/5. The first thing we need to do is the order of operations. The order of operations dictates that because division and multiplication has the same rank, we do what comes first from left to right. So we would do the multiplication. So let's first simplify this out. This would be 3 times, and we have 3 2's for the 8. And 4 breaks down to 2 times 2, and 9 breaks down to 3 times 3. We have one set of 3's and 2 sets of 2's. So we would be left with 2/3. And then bring down our divided by 2/5. So now, 2/3 remains the same. Division becomes multiplication, and we take the reciprocal of the second fraction. Now, we will multiply. We add 2 times 5 over 3 times 2. These 2 simplify out, and your final answer is 5/3. Now we go here to number 6. We have division and multiplication. Same rule applies. Whichever one comes first from left to right, and division came first here. So we'll put a 1 under this 1 here. So we have 1 over 1. Division becomes multiplication, and we take the reciprocal of the second fraction. So 1 times 4 is 4, and 1 times 3 is 3. So we have 4/3 times the 2/3 that was left over. Now, we know 4 breaks down to 2 times 2, and we would have 3 2's and 2 3's, which we cannot simplify out. So we'll multiply. 4 times 2 is 8, and 3 times 3 is 9. So that is our final answer. Now we scroll down to objective E. It says to find a fraction of a number, multiply the fraction by that number. Example, find 3/5 of 40. So that'll be 3/5 times 40. And we'll make that 40 over 1. So we'll take the prime factorization. 3 times 40 breaks down to 3 2's and a 5. And then we know the prime factorization of 5 is 5. And we don't need to write the 1 here. So these 5 simplify out. And then we will have 24 over 1, which is 24. Now we go down here to number 2. A salesman gets paid a commission of 2/15 of the total amount of sales. Last week he sold $4,800 worth of merchandise. What was his commission? Now it's 2/15 of total sales. So we'll take 2/15 times his total sales was $4,800. And we'll put that over 1. Now we need to go off to the side and find the prime factorization of 4,800. Now what I'm going to do is, to make this a little easier, I'm going to take 48 times 100. 48 we know is 2 times 24, which breaks down to 2 times 12, which breaks down to, we know 12 breaks down to 2 2's and a 3. So here we will have, what's that, 4 2's and a 3. That'll take care of 48. Now 100. We know 5 times 20 is 100. 20 breaks down to 5 times 4, and 4 breaks down to 2 times 2. So that means we have 2 5's and 2 2's. So we break this down to prime factorization. This would be 2 times, we have 1, 2, 3, 4 2's. Then we have 2 more 2's here. Then we have a 3 and 2 5's. Then our denominator to be 3 times 5. Now we know we have one set of 3's and one set of 5's in common.